Good evening, class. We are looking at practices number 4, module 4 covering chapter 7 and 8. And here's chapter 8, analytic geometry. All right, we want to find an equation of a circle with its center at 1, -2 and radius 2. We're going to graph the circle. So let's remind everybody about circles. Number 1, circle is defined as follows. A circle is the set of points in a plane that are the same distance, called the radius, from a fixed point called the center. When the center is located at the origin, the formula is x squared plus y squared equals r squared. If it's located at h and k, x minus h quantity squared plus y minus k quantity squared equals r squared, and it follows Pythagorean theorem or distance formula. So these are the general formulas. Now, reminding you, the area of any circle is pi r squared, and the center is equal to 2 pi r. And these are some basic information that we've had from before. Now, so in this case, what is given? The radius is 2, and the center is located at 1, -2. We could just call it C. And according to this formula, x minus h squared, so x minus 1 squared plus y minus k, y minus -2 makes it plus 2 squared, r squared, 2 squared, or 4. So that should be fairly simple to follow. Now we can locate, in order to graph this, there are easy points. We can locate the center and then go r units to the right and left, r units up and down. So here's the center located at 1, -2. So we can go to the right and left, up and down by how many units? By r units. So 2 units left and right. So if this one has coordinates 1 and -2, 2 units. So for the x coordinate, add 2 becomes 3, -2, subtract 2. So from this point, go 2 to the left, 2 to the right. So when you go 2 to the left, 1 minus 2 makes it -1. So those are the points. Now going back to the center, now r units up, r units down. If I want to go up, so I keep the x coordinate up by how many units? By r units gives me 0. Down by r units gives me -4. So these are the 2 points for the right and left. Now 2 units up and down. 1, 0, 1, -4. And this is a rough sketch. And we are done. Write the equation of a circle in standard form, meaning either this one or that one. Identify the center and the radius, graph the circle. Well, we are going to put the x squared and -4x together, y squared and 10y together, and we move the constant to the other side, becomes positive. We make this into a perfect square trinomial. Here's B. We divide it by 2, you get -2, u squared, you get 4. So you add 4 to both sides. Here's B, divided by 2 is 5, squared is 25, added to both sides. Okay, so this one would be -2 squared, and this one would be 5 squared. So this gives us x minus 2 quantity squared. This gives us y plus 5 quantity squared, and these numbers add up to 36. Therefore, the radius is square root of 36, or 6. It is centered at 2, -5. So let's locate the center here. 1 and 2 and 5 down. we are starting from the center. We go 2 units to the left and right. R units, my apologies, R units. Whatever R is, 6. If I go to the right, 6 and 2 gives me 8, comma negative 5. If I go to the left, 2 minus 6 gives me negative 4, comma negative 5. Now, going back to the center, up and down by R units. So up and down, leave the X coordinate alone, go up, that means add 6, you get positive 1. Subtract 6, you get negative 11. So those are the two pairs. And put them all together, there you have it. Again, this is one easy way to graph this. Graph the ellipse by finding its center and vertices, x squared over 25 plus y squared over 16 equals 1. Well, what is an ellipse? In this case, it's elongated along the x-axis, a point with name P with coordinates x and y. We have focus 1 and focus 2. If it's centered at the origin, it looks like that. F1 has coordinates negative c comma 0, and this one has c comma 0. So this distance is c, this distance is b, this distance is a. So let's plug it in. So this distance is a, this distance is b, and this distance is c. An ellipse is defined as follows. An ellipse is a set of points in a plane, the sum of whose distances from two fixed points is a constant. The two fixed points are called the foci, each is a focus of the ellipse. F1 and F2 represent the two foci of an ellipse. Now PF1 plus PF2 is constant. It happened to be 2 times A. If I pick another point and I connect them to F1 and F2, it works the same way. Call this Q. QF1, QF2 does the same thing. And the same thing happens for here. The distance from here to here and from here to here, they add up to a fixed number. Because of the symmetry, this part is equal to this part, and it gives you 2a. Now, as far as the equations are concerned, if it's centered at 0, 0, x squared over a squared plus y squared over b squared equals 1. If it's centered at h comma k, x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. And the area is pi times AB. I hope you remember that ellipse and circle, the relationship is that circle is a special case of an ellipse where A and B are identical. So when if they are identical, becomes r times r becomes pi r squared for a circle. And the relationship between A, B, and C is such that B squared plus C squared equals A squared. Now, if it's elongated along the y-axis, the B value is larger than that. By the way, in some texts, they may change them and they keep the A as the larger one. I suggest you keep the A under the X and B under the Y always. So with this being the case, when you compare, you notice the center is located at 0, 0. A squared is 25, so A is 5. B squared is 16, so B must be 4. So that should be easy. All you have to do, compare this with this one, and you get this result, right? So again, A squared is 25, we get A equals 5, B squared is 16, we get 4, and center that's 0, 0. So the vertices, because A is longer, are considered the vertices are at 5, 0, and negative 5, 0. So here's the center, 0, 0. And here's the vertices at 5, 0, and negative 5, 0. Now, co-vertices, okay, up, down, and up and down here, are located at, because B is 4, at 0, -4, and 0, +4. And if you put them together, that's the graph of an ellipse. Identify the coordinates of the center, the vertices, the co-vertices, and foci. Graph the ellipse. X plus 5 quantity squared over 4 plus y minus 7 quantity squared over 9 equals 1. And we are going to compare this to this one. And clearly, the center is located at -5, +7. A is 2, because you're going to take a square root of 4. And B is square root of 9 or 3. So that's just by comparison. Compare these two, we get those values. So let's plug in the center. The center -5. So this is -4, this is -6, -5 is here. And 7, this is 8, this is 6, so 7 is here, somewhere there. Yeah. So that's the center. Now, because B is larger than A, it's elongated along the y-axis. So the vertices would go from the center B units up, B units down. So if I want to go B units up, I'm going to add 3 to 7 becomes -5, 10. If I want to go down, I'm going to subtract 3, -5, comma 4. Okay. -5, comma 4, -5, comma 10. As far as the co-vertices are concerned, we are going to go back to the center, and now we're going to go left and right by A units, left and right by A units. So left and right means just don't change the y, this one. If I want to go to the right, I'm going to add 2 becomes -3 if I want to go to the left. So left, subtract 2, right, add 2 to the x coordinate. So if I subtract, I get -7, 7. If I add, I get -3, 7. Put them together, that's your graph. Now, as far as foci is concerned, the formula is a squared plus c squared equals b squared, or b squared plus c squared equals a squared, because sometimes a is larger, sometimes b is larger. It follows Pythagorean theorem. The largest one is on the right side of the equation. And as you know, in this example, b is larger. So therefore, we're going to stick with this formula. Okay. So a was 2, b was 3, c is missing. So this is the 4. This is 9. So c squared is 9 minus 4 or 5. C is square root of 5. So square root of 5, it's a little bit more than 2, but 2.243, something like that. So because it's elongated along the y-axis, and those are the vertices, then the foci are also along the same line. So from the center, you go up by square root of 5. That would be one of the foci. From the center, you go down by square root of 5. And that's the other one. So the x coordinate doesn't change. The y, you subtract and add square root of 5. So -5, 477 minus 5, 924. Those are the two pairs. And here's the graph. Okay, everybody. So we have the vertices, co-vertices, the center, focus 1, or focus 2, two foci. Use the graph of the ellipse to determine the equation in standard form, and again reminding you of the standard form and all the information that was given. So we are going to use this one because the center is not located at 0, 0. And what we are going to do, we're going to locate the center, negative 2, comma 2. We need the vertices. So this one is located at negative 2, 5. This one is located at negative 2, negative 1. And so right here, this distance is, because this is larger than this distance, is A. And if you notice, this has coordinates 0, 2. This has coordinates negative 4, 0. So this distance is your A, and this distance is your B, and clearly this is actually your B because it's elongated along the y-axis. So this is your B, 1, 2, 3, or you can say, for example, 5 minus 2. So this distance is 3, and this distance is 2. Therefore, A is 2, B is 3. Now, replace the H and K with the center. So x minus negative 2 makes it x plus 2 quantity squared over A squared over 4 plus y minus k quantity squared, y minus 2 quantity squared over B squared, 3 squared, or 9. And that's the equation. Given the equation of asymptotes, give the equation of the asymptotes and graph the hyperbolas. One of them is x squared over 16 minus y squared over 25 equals 1. The other one is y squared over 25 minus x squared over 16 equals 1. So first and foremost, let's go with the definition, reminding everybody of what a hyperbola looks like. We have the general formula x squared over a squared minus y squared over b squared equals 1, or y squared over b squared minus x squared over a squared equals 1. And if you keep the a squared under x squared and the b squared under y squared in both cases, the equation of asymptote remains unchanged. Y equals plus minus b over a times x. That's one thing to know. And of course, in this example, this one, it opens sideways. If we happen to have this one, it opens up and down. Okay, so this opens up and down. Therefore, we already know this one opens sideways and this one opens up and down with the same asymptote. Okay, and here's the definition. A hyperbola is a set of points in a plane, the difference of whose distances from two fixed points called the foci is a constant. So if you pick any point and connect it to F1 and F2, PF1 minus PF2 is a constant 2a. If I pick another point and connect them, the same thing. Now, this distance is A, this distance is B, and the setup of a hyperbola is such that C, whether it opens sideways or up and down, the value of C is always the largest among A, B, C. Therefore, A squared plus B squared equals C squared. Always, this doesn't change. Now, what I want you to notice is this. This one is the center that's 0, 0. This one has coordinates a0. This one, therefore, it has coordinates negative a0. 0b, 0 minus b. If you draw this is called fundamental rectangle. Let me write that for you. So this is called fundamental rectangle. So this would have the equation b over a times x. Remember, it's plus minus, and this is the second line, minus b over ax. So this fundamental rectangle will help you draw the two asymptotes. You don't need to have that one. You can just draw the two lines. Either way it works, okay? But if you draw the rectangle, it helps you. The diagonals are the two lines. So in this case, both of them, the location of a center is 0, 0. Both of them, A is 4, B is 5. Okay. And therefore, both of them, the equation of an asymptote y equals plus minus b over a, 4 over 5, 5 over 4x. So these are the two, okay. And the equation for this one, y equals 5 over 4 times x. For this one, minus 5 over 4 times x. Now, the vertices for this guy, the vertices are 4, 0, minus 4, 0. This opens sideways. Now, this is the same. So, 4, 0, minus 4, 0. This is the same asymptotes, but for this case, the vertices are located at 0, 5, and 0, negative 5. So that's this one. That's the graph. This is 0, 5, 0, negative 5, and that's the graph. Notice, at first I drew the line, but then they have to be dashed lines. They are not part of the graph, everybody, okay? They are not part of the graph, and you want to be very careful with that. All right, identify the coordinates of the center, the vertices, foci, and the equation of the asymptotes, graph the hyperbola. Again, reminding you that if we happen to have a hyperbola centered at a different point, here's the equation. X minus h quantity squared over a squared minus y minus k quantity squared over b squared equals 1. Or we may have it as y minus k quantity squared over b squared minus x minus h quantity squared over a squared equals 1. At which point, if you recall, it was y equals plus minus b over a times x. So it has shifted by k and h. So you do exactly the same thing. You put the minus k next to y, and you put the minus h next to x. And those are the equations of the asymptotes. As far as a squared plus b squared equals c squared does not change. So what do we have here? Centered at 1, 2. And we're going to compare this because x minus 1 squared, compare it to this one. So let me. So therefore, a is square root of 9 or 3, b is square root of 16 or 4. going to put this as the formula for the asymptotes. So y minus 2 equals plus minus b over a 4/3 x minus 1. If you move this to the other side, you get those. Of course, this can be simplified. Okay. So you have positive 4/3 times x minus 1 and negative 4/3 times that. So let me show you if you go with the positive 4/3, for example, and then I clean it up, okay? If I just go with the positive 4 now, I get 4/3 x minus 4/3 plus 2. Okay, so these two add up. Okay, 2 times 3, 6 minus 4. They add up to 2/3. Okay, you get this one. If I go with the negative, so minus, okay, so if I go with minus 4/3 times x minus 1 plus 2, I end up with minus 4/3 x plus 4/3 plus 2. And these two add up to 2 times 3, 8 times 2 times 3, 6 plus 4 is 10/3. So those are the equations. So if we stick with this one, I hope you notice 0 2/3. Okay, 0 2/3 is the y-intercept. So this is the y-intercept. If you set this equal to 0, let me just show you that one also. If I set y is 0, I get 4/3 x plus 2/3. And I hope you see that I can move the 2/3, making it minus 2/3, 4/3 x, and can drop the denominator, and x becomes negative 1/2. So I have those two pairs. Okay. And this is the one I just calculated for you. And in the same manner, as 0, 10/3 is the y-intercept. If I set this one equal to 0, then 4x becomes 10 and x becomes 5/2. So those are the pairs. Let me clean up the mess. So these are the two lines. Okay, these are the two lines. Basically, 0 2/3 minus 1/2 0 roughly. 0 10/3 5/2 0. So those are the two lines. Of course, they have to be dashed lines, but we will take care of that later. Okay. All right, so the center is located at 1, 2. As you can see, this is, by the way, the scale along the x and y axis, they don't have to be the same. So in this case, they are practically the same. This is 1, this is 2, so somewhere here. Okay. Now, A is 3. So if A is 3, we are going to, and this opens sideways, right? So we are going to start from the center and go A units, meaning 3 units, to the right and to the left. So to the right of this, okay, to the right of this, you add 3 to 1, you get 4, 4, 2. To the left of this, you subtract 1 minus 3, negative 2, 2. So you get those 2 points, okay? So 3 to the right, 3 to the left. Of course, practically, you're ready to graph it. That's good enough. But a squared plus b squared equals c squared. And c becomes 5 because this is 3 squared plus 4 squared, 9, and 16 is 25, so C becomes 5. And so if C is 5, we go 5 units to the right and left of the center. So that from the center, which is located at 1, 2, if I go to the right by 5, 1 changes to 6, 6, 2. If I go to the left, 1 minus 5 becomes negative 4. Here's the graph. Here's the asymptotes. Use the graph of the hyperbola to determine its equation in standard form. So of course, they then give us the asymptotes, but those are the asymptotes, okay? It goes through the center, okay? The center is given as negative 1, 0. The foci are at negative 1, 3 squared of 2, negative 1, minus 3 squared of 2, and the vertices are negative 1, negative 3, negative 1, 3. And so we are going to write the center and we want to find A and B. Of course, this distance is B. Why is it B? Because we are using this formula. When it opens up and down, we use this formula, everybody. Therefore, it's this distance, which is simply 3. That's the value of B. Vertex is located at negative 1, 3, and negative 1, negative 3. So B units up and down, this distance is 3 units. Foci has the distance of 3 squared of 2. So it's located at negative 1, 3 squared of 2, and negative 1, negative 3 squared of 2. So the C has a value of 3 squared of 2. So B is 3. Foci are located C units up and down from the center. And C is 3 squared of 2. A squared plus B squared equals C squared. So we find the missing A. We plug in B is 3, C is 3 squared of 2. Of course, this becomes 9. Everybody knows that. This becomes 9 times 2. Please understand, square root of 2, when you square it, becomes 2. 3 becomes 9. Their product is 18. And so we're going to subtract 9 from it. Gives us 9, and A becomes 3. So we use this formula. We have everything. We have the center, so y minus 0, or simply y squared over b squared over 9, minus x minus h, that means x minus negative 1 or x plus 1 quantity squared over a squared 9 equals 1. So that's the equation. And practically we're done. But if we wanted to figure out what is the asymptote, we can go with this. Y minus k, that means y minus 0 equals plus minus b over a, 3 over 3, which makes it 1x plus 1. And I hope you see this is 1. So y is plus minus x plus 1. So either x plus 1, y is x plus 1, or y is minus x minus 1. That's the idea. So we can figure out what's going on here. And pay attention to this distance. That gives us p equals 3. And the asymptotes and their dashed lines. A parabola is defined as the collection of all points P in the plane that are the same distance d from a fixed point F as they are from a fixed line D. The point F is called the focus of the parabola and the line D is its directrix. As a result, a parabola is the set of points P for which the distance F comma P is the same as the distance P comma D. So we've seen equation of parabolas before, but we want to look at from this point of view and the meaning of the definition. So if you have a parabola and you pick any point, and if you find the focal distance, the distance from that point to this point, which is the focus, this distance is the same as the distance from that point to a directrix. So you drop a perpendicular, that is always perpendicular. That is the definition. If I pick a point here and drop perpendicular to directrix and draw this line, distance from that point to F is the same. If I pick it from here, this distance and this one is the same, okay, and so forth, okay. That's as far as the definition. Now, this is the format we are using here, okay. Y squared is 4px, y squared is minus 4px, x squared is 4py, x squared minus 4py, and so forth, where p is 1 over 4a or 1 over 4p. What I want to remind you is what we did in intermediate algebra. This was one format, y equals ax squared plus bx plus c. Remember, when x is to the second power, this opens up or down depending on the value of a. If it's positive, opens up. If it's negative, opens down. And if we want to write it using the vertex, a times x minus h quantity squared plus k. Everybody remembers that. Now, if x is equal to ay squared plus by plus c, now this opens sideways. If a is positive to the right, if a is negative to the left, and the formula is a times y minus k squared plus a. This is what we remember. Now, what I'm writing down here is the relationship between this a and this p. Sometimes even the p is called a depending on the text. So, in fact, that's what they're doing it here. It's the focal distance. This distance, everybody, the distance here is the focal distance. The distance from the vertex to the focus. This distance is P. And because it's the same distance here, if you look at this point, this distance must be P also, by definition of a parabola. So with that being the case, let's also define lattice rectum, which by definition, the lattice rectum of a conic section is the chord or line segment in essence through a focus, parallel to the conic section directrix, and it's 4p. So here's the directrix, and here's the focal point. You draw a parallel line. This distance is called the distance for a lattice rectum, and it's equal to 4p. Why is it equal to 4p? First, this distance, everybody, is p, so is this distance, right? By the definition. Let me just use some. Okay. This distance, everybody, this distance is the same as this distance, and each one is p by definition. So if that is the case, this is p, this is p, so this is 2p. So at this point gives you this distance equal to this distance, which is 2p. They are using a, okay, class. And this distance is the same 2p, so 2p and 2p gives us 4p. By the same token, if we want to go with this, where again, remember, this opens up and down, this opens left and right. When y has a second degree up and down, when x has a second degree up, when x has a second degree up and down, when y has a second degree sideways. So we can see this formula, y squared equals 4px, y minus k quantity squared is 4p times x minus h. And what matters, if you look at this formula that we have, the relationship between a and p is that a is 1 over 4p, or you might say p is 1 over 4a. This is the a we used in algebra, and we're going to keep it, okay? Identify the coordinates of the vertex, the focus, the length of the lattice rectum, and the equation of the axis of symmetry and the directrix. Graph the parabola. And everybody remembers what we learned in intermediate algebra. But just to give you an idea, y is the one with the second degree. So this opens sideways. Is it going to open right or left? This open right because the if you consider x equals y squared, okay, and this is x equals y squared in essence, if you don't regard the vertex, it opens to the right. So you already know it opens to the right, okay? So where is the vertex located at? -4, 2. Again, you can either compare this. You can also go to change it and write it as an intermediate algebra format. I will show you when we do that. Compare it to this one for now. And so because it opens sideways, remember when it opens up and down, you have the axis of symmetry that is x equals the x coordinate of the vertex. When it opens sideways, it's a horizontal line, axis of symmetry, y equals the, again, location of the vertex, and for the y, in this case, y equals 2. So we have the center, the vertex at -4, 2. We have the axis of symmetry, y equals 2. And 4p is 4 over 5. P becomes 1/5 of 0.2. What does it mean? It means from the vertex, I go this amount, p units to the right, give me the focal distance. Okay. So we are going to add the p. -4 plus p makes it -3.82. So that's this point. The directrix is a vertical line. See, this y equals 2 is the axis of symmetry, directrix is a vertical line. And now the same thing, you go to the vertex and you go p units to the left of that, okay? So x equals this x coordinate of the vertex, and you're going to subtract this number from it. So -4 minus p, which means -4 minus 0.2, which means -4.2. And that is the directrix. This is the graph. This distance is called the lattice rectum, okay? Reminding you of the definition. And it's equal to 4p. 4p is 4/5 or 0.8. If you're more comfortable with just the algebra, intermediate algebra that we've seen, you can make the change as follows. I'm going to quickly show you. If you write this as 4/5 x plus 16 over 5 and move this way, you get x equals y minus 2 squared I mean 4/5 x is y minus 2 squared minus 16 over 5. Now you multiply both sides. Actually, it's better that, we multiply it right here by 5/4 here. So let's multiply it right here. Let me just erase it. If I multiply this one by 5/4 and this one by 5/4, then we get 5/4 y minus 2 squared equals x plus 4. Therefore, 5/4 y minus 2 squared minus 4 equals x. If you are more comfortable using that, that's fine. But understand how we calculate the p, the focal distance, okay? Use the graph to determine the equation in standard form, and this is the format that they want. So, and I'll show you both ways. And notice here's the vertex, here's the focus, and so on. So if we use x squared equals 4py, because remember, when it opens up and down, x has the degree 2. Therefore, we're going to use x minus h squared equals minus 4py minus k. The reason is negative because it opens down. And again, I'll show you both ways. So the vertex is located at negative 3 comma 5. The focus is located at negative 3, 319 over 64. So those are given from the graph. So this distance is the value of p. So how do you find this distance? Because they have the same x coordinates, 5 minus 319 over 64. And when you take a common denominator, you simply get 1 over 64. Now we just follow that. X minus h quantity squared becomes x minus negative 3 or x plus 3 quantity squared minus 4 times p, or 1 over 64 y minus 5. This becomes negative 1 over 16. So this is the standard form. Or we could do the following. If we want to stick with intermediate algebra, you can go with this formula. Use the vertex. So y equals a times x minus negative 3, meaning plus 3 quantity squared, plus 5. We have already found the p. We're going to use that because of the distance between the two is the p. And we know that the relationship between p and a, p is 1 over 4a, or a is 1 over 4p. So a is 1 over 4p. Because it opens down, it's negative, right? So 1 over negative 4p. So 1 over negative 4 times this number. And this becomes negative 1 over 16. Let me just write that for you. This whole thing is negative 1 over 16, and the answer is minus 16. So here's the equation in standard form that we have seen before in intermediate algebra. And then you can make the change if you need. So I hope you're comfortable with those. Given the function expressed in standard form, f of x is a times x minus h quantity squared plus k. This is a standard form we used in intermediate algebra. You can stick with that. So whenever they say standard form, see the format they are asking. And find the x-intercept, the y-intercept, the vertex, find the axis of symmetry, graph the function. And so it's given in this format. In order to put it in the format, which in many texts they call it vertex format because it's given the vertex. Then what you do, you take the 2 out from these 2, you put them together and you take the 2 out. And now you are going to complete this square. Remember, b is 2, divided by 2 becomes 1, squared becomes 1. So you are going to add 1 inside the parentheses. But remember, when you add 1, in essence, you're adding 2 times 1. That's why you undo it with -2. I want to make sure we understand what happened here. If instead of 2, I had 5, then I'm adding 5 times 1. So I'm going to have -5 there. So this -2 comes from the fact that there's a 2 in front. And so therefore, this becomes 2 times x plus 1 quantity squared plus 4. And now the vertex is located at -1 comma 4, and it opens up. So -1 comma 4, and it opens up. So we don't have any x-intercepts. First of all, it opens up. It can't have an x-intercept. The other thing is that if you look at this function and calculate the b squared minus 4ac, it ends up being negative, has no solutions. I hope you remember that from before when we discussed quadratic functions. So if you set this equal to 0, since b squared minus 4ac is negative, doesn't have a real solution. The y-intercept is easier to use this one. If x is 0, you get 6. So 0 comma 6. And if we go by the axis of symmetry, because vertex is located at this, so x equals -1. So this is the axis of symmetry. By symmetry, if this is a point, you go the same distance here. This is another point there. And that means, what is this distance? 1, you go 1 further on this side, and you get -2 comma 6. And that's the other point. That's the graph because it opens up, and we are done. Identify the graph of each equation. Well, if we put them in standard form, we know what we have. But if you want to identify it quickly without doing much, here's how you look at it. When it's on the same side, and by the same side, I'm talking about these two, x squared and y squared. If they are both having identical coefficients, the coefficients are the same, equal coefficients, and it's a circle. Oh, it's a circle. Now, if they are not equal, but they have same sign, it's an ellipse. If you bring it to the same side, doesn't matter, you keep the 144 on the left or right. We're talking about x squared and y squared. If they have different signs, it's a hyperbola. Okay. We're talking about this coefficient is positive, this is negative. It doesn't matter which one is which. Now, By the way, h of x is the same as y. I want you to understand this can be replaced with y. So when you have one of those, either x or y, not both, have second degree, then it's a parabola. So all of these are parabolas. If x is of degree 2, it opens either up or down. Because a is negative, it opens down. This one opens up because a is 1 and it's positive, and we have x squared. Now, the other one, it either opens to the right or left, and opens to the right because the coefficient of y squared, a is 1 and it's larger than 0, opens to the right. So pretty straightforward, everybody.